Today we are going to learn about GIC and NIC. So first I am coming for NIC. NIC stands for Negative Impedance Converter. What it actually do? This particular circuit converts positive resistance into the negative resistances. So sometimes, especially in the case of oscillators, negative resistance are used. So for that one, this NIC circuit is used. Now we will see how we will make NIC circuit use op amp. So I am making the op amp. So this is the op amp. Instance here minus plus this point is the R1 RF. This positive terminal I am having one resistance, its value is Z. Now I am having a source, this source is V in, current is I in, and this is the output node V out, and this is VP. This point is Vn. So this is my circuit diagram. Now let us see. If we see what happens, this particular circuit looks like that it is in non-inverting amplifier. So V out equal to, we can write 1 plus RF by R1 into VP. My VP is equal to V in. That's why my V out equal to 1 plus RF by R1 into V in. Suppose let RF equal to R1, then my V naught equal to 2 into V in. So my output voltage is twice of the input voltage. We apply KCL at node VP. So at this particular point we are going to apply the node KCL. So what will happen? I in equal to V in minus V naught by Z. So substitute the value of V out. So V in minus 2V in upon Z. So I can write this is a minus V in by Z. So if we are going to see, then V in upon I in, which is also known as Z in, is equal to minus Z. So it says that if we are looking from the input side, from this side, we are going to see that the whole circuit behaves like a negative impedance and its value is equal to minus Z. So this way we are going to create a negative resistance circuit. Then people have started to think, can we make generalized impedance converter? So answer is yes. So now we are going to see about generalized impedance converter, which is called GIC. GIC stands for generalized impedance converter. So this particular circuit is used to convert the input impedance to a capacitor or inductor. This is also known as a circuit which will implement inductor while circuit doesn't have inductor. So already we know that making of inductor is very crucial inside the chip. So this particular circuit is used to realize the inductor with the help of capacitor. How it is going to be happen, we will see it here. So first I am going to draw the circuit. So this is my V in. See the circuit carefully. Z1 we are having 5 impedances, Z2, Z3, Z4 and Z5, and this goes to ground. Now we are having here 2 op-amps. One op-amp is here, connected to here, plus sign, minus sign. Second one is here, minus plus sign, plus is connected to here, minus is connected to here. Now output is connected between Z3 and Z4, and this output is connected between Z1 and Z2. This is the complete circuit diagram. To understand the working of it, we are putting some node names. So for this is my op-amp number 1. So I am going to take, this is my first op-amp, this is my second op-amp. So output of the first op-amp I am going to put as V01, or second op-amp is V02. At this point I am going to consider a node A, and at this point between Z4 and Z5 I am going to consider node B. Now we have considered it. So if we see for the op-amp 1, in op-amp 1 what is happening, my output V01 is connected to the negative terminal via Z3 impedances, you can see here. Similarly, my op-amp 2, the output is connected to the negative terminal of the op-amp via Z1 impedances. So it says that both the op-amps are in the negative feedback. So virtual ground concept will exist here. So now what happened? We are going to apply the KCL. So apply KCL at node A. So we are going to apply KCL at node A. What will happen? V02 minus VA upon Z2 will be equal to VA minus V01 by Z3. Now look it carefully. What is happening? V in is the potential here. So V in is available at positive terminal of the op-amp 1, as since it is a negative feedback, so virtual ground exists. So this V in is also available at negative terminal, means at node VA. So my VA is equal to V in, substitute it. So V02 minus V in upon Z2 is equal to V in minus V01 upon Z3. So this is my equation 1. Next equation I am going to use at apply KCL at node B. So we are going to apply KCL at node B. Then what will happen? At this particular node, V01 minus VB by Z4 is equal to VB by Z5. Since in op amp there is no input current, so that's why we are able to write this. So what is VB? Again see the diagram. So Vin comes here, so Vin is available here. Since Vin is available here and there is a negative feedback, it means that VB is also having a voltage of Vin. So VB equal to Vin. So what will happen? V01 minus Vin by Z4 is equal to Vin by Z5. So from this we can write V01 is equal to what? Is equal to Z4 plus Z5 divided by Z5 into Vin. So this is my equation number 2. So equation 2 says that my V0 is equal to Z4 plus Z5, because I am turning to this side. So it becomes Z4 plus Z5 and denominator Z4 into Z5. So Z4 is going to be cancelled. So this is my equation 2. Now we are going to substitute equation 2 in equation 1. Equation 2 in 1. What we are going to have? If we are going to substitute them, then V02 by Z2 equal to, we can write Vin 1 plus Z2 plus 1 plus Z3, and the case minus 1 upon Z3. In the place of V01 we are going to substitute this Z4 plus Z5 by Z5 into Vin. So we are taking Vin and solving it. So what we are going to have? So in the denominator we are going to have Z2, Z3 and Z5, and the numerator side we are going to get Z2, we are going to get Z3, Z5. In the case of Z3 we are going to have Z2, Z5. Here we are have minus Z4 and Z2, and this side we are going to have minus Z2 and Z5. So Z2, Z5 cancelled out. So we are going to have this will equal to Vin Z3, Z5 minus Z4, Z2 divided by Z2, Z3, Z5, and this whole is equal to V0 by Z2. So Z2 cancelled out. So we are going to have V02 equal to Vin Z3, Z5 minus Z2, Z4 divided by Z3, Z5. So this is my equation number 3. So now we are having the value of V01 and V02 in terms of Vin. Now applying KCL at this particular node. So I am going to talk about this particular node. Let's say this node is X. So at node X, what is going to be happen? So at this particular node X, this is my input current. This is IN. This is coming from here. So I can write IN current is equal to Vin, which is the voltage at the X terminal, minus V02 upon Z1. So now we are going to substitute the value. So V in by Z1 minus V02 by Z1. So I am going to substitute the value. So what is going to happen? So this will be V in 1 by Z1 minus, what is value of V02? We have calculated. So first I am going to write Z1 and then V in equal to V in into Z3 Z5 minus Z2 Z4 all divided by Z3 Z5. Now, so I am going to take V in by Z1 common. So V in by Z1 I am going to take common. This becomes 1 minus Z3 Z5 minus Z2 Z4 divided by Z3 Z5. Now we are going to simplify it. So what will happen? So this will happen V in upon Z1 in the bracket Z3 Z5 minus Z3 Z5 plus Z2 Z4 all divided by Z3 Z5. This is cancelled out, so I can write I in equal to V in Z1 into Z2 Z4 divided by Z3 Z5. So I can write simply V in upon I in, which will be known as Z in. This will be equal to Z1 Z3 Z5 all divided by Z2 into Z4. So this is called GIC. Now, why it is very important? Very much importance is given to this particular circuit. So what is the reason behind it? So we are going to see here. Let us say, let Z4 is equal to 1 upon j omega c and rest Z1 and rest are resistance. Then what will happen? My Z in will be equal to j omega c R1 R3 R5 by R2. So when I am going to see from this, it seems that since there is a j omega and this pole behaves like a L, so this is an inductor and this becomes L, and the value of L will be C R1 R3 R5 by R2. This is L, inductor. So whole my circuit is going to realize as an inductor. That's the advantage of this particular circuit. Similarly, if you want to make a negative resistances, you can create it. So what will happen? This time you take Z2 and Z4 as a capacitance. So for negative resistance, you take for negative resistance Z2 and Z4 should be capacitor. Then what will happen? J omega and j omega, both j omega will come into the numerator and j into j becomes j square, value becomes -1, and then all are the resistance. Whatever value we are going to have at that time, what will happen? We will have R1, R3, R5, C1 and C2. So this will be the value of impedances, means the value of capacitance, impedance. and negative sign will come here. So by this way, and into omega square. So this way we can create a negative resistances. You can realize the capacitance also. So that's why its name is general impedance converter. So in the next class we will learn about the numericals on the GIC. So I hope you have understood the concept of GIC as well as NIC. Thank you.